Hi and welcome. I'm trying to learn cytology today. Transport across the plasma membrane, and after we've done it, we're gonna do extensor kappa analysis strength training. And if you participate in the extensor kappa analysis strength training, then it's very honest. Transport across the plasma membrane. Transport of materials across the plasma membrane is essential to the life of a cell. It needs supply. Certain substances must move into the cell to support metabolic reactions. Others must be moved out because they have been produced by the cell for export or are cellular waste products. Some have to go in so that the metabolic reactions can run. Others have to be out because they are waste products or are specifically produced for the export. As you have seen, some substances can cross the lipid bilayer portions of a plasma membrane, whereas others use channels or transporters formed by membrane proteins. Now, what substances could cross the lipid bilayer at all? They said water. We've been talking about the few ones. It could just through. Okay, let's go on here. So some can go through, others having specifically channels or transporters. So a specific ligand, specific substance comes on and it brings it in, or channel letting through a specific substance or something. Substances cross cellular membranes via transport processes that are classified according to two criteria. One, whether they are mediated or non-mediated, and two, whether they are active or passive. Okay, there can be active and passive transportation modi, and they can be mediated or non-mediated. I don't know what mediated means. In mediated transport, materials move through the membrane with the assistance of a transporter protein, whereas in non-mediated transport, no transporter protein is involved. In passive transport, a substance moves down its concentration gradient across the membrane using only its own kinetic energy of motion, whereas in active transport, cellular energy, usually in the form of adenosine triphosphate, is used to drive a substance upward against its concentration gradient. Okay, I get what I mean. So some are passive, they are just going in, like water just spreading. So substances can be just go in, and they can be active transport. The adenosine triphosphate are used like little transportation mechanisms to help them bring them in. And mediated and non-mediated, I think that means that a substance is added to it or something. No transporter protein is involved by non-mediated, so that the protein comes to it and is helping. These channels, are these proteins? No, not like that here. Transporter also not. Receptors, not said. The receptors are not bringing in. Yes, we're doing the vesicular transport. Later. No. Living cells use three passive transport processes. Two of these are non-mediated: diffusion through the lipid bilayer and diffusion through a channel. Okay, non-mediated, so no protein is added to bring it through. And that can be through a channel or just directly through the whole lipid bilayer. One passive process, facilitated diffusion, is mediated. Among active transport processes, all of which are mediated, we can distinguish several types of transporters. So, what was the sentence? One passive process, facilitated diffusion, is mediated. The facilitated diffusion, okay, we explain it here somewhere. Among active transport processes, the active transport processes, that is where the adenosine triphosphate are helping to bring it in. So among them, all of which are mediated, so the one where protein is added, we can distinguish several types of transporters. Uniporters move only a single substance across the membrane. In coupled transporters, two substances move across the membrane together. Coupled transporters are either. Is there any type of virus which is coupling up with another virus and is then able to enter into cells? In coupled transport, two substances move across the membrane together. Coupled transporters are either symporters which move two substances in the same directions, or antiporters, which move two substances in opposite directions across the membrane. Another way that materials may enter or leave cells is by processes that involve the formation of membranes surrounding vesicles. That's okay. In vesicular transport, tiny vesicles either detach from the plasma membrane while bringing materials into the cell, or a process called endocytosis, or merge with the plasma membrane to release materials from a cell, a process called exocytosis. Large particles such as whole bacteria and red blood cells and macromolecules such as polysaccharides and proteins may enter and leave cells by vesicular transport. Okay, we read it short in vesicular transport. They had an interesting name for it. Libra something. Clefairy. The clefairy. They are splitting, not completely off, they are coming together, and they are splitting off or something, taking it in and then we're going through. Okay, what we did say, there is active transport and passive transport. Active transport, a protein is helping the thing to come in. Passive is it just goes through the channel or just directly to the lipid bilayer. It can be mediated or non-mediated. Mediated, there's a protein went to it, and non-mediated, there's no protein to it. And now let's look what we mentioned there, if they say it is somewhere. With the indiffusion, what it was. Figure 35, processes for transport of materials across the plasma membrane A. In passive transport, in passive transport. In passive transport, a substance moves down its concentration gradient across the membrane. Whereas in active transport, cellular energy is used to drive the substance against its concentrated gradient. Could it be that sometimes active transport is used with a concentration gradient, like a booster, so bring it even faster? Or the other way around, is it okay? I don't know, but basically the question is, does it always work perfectly, and only the ones which don't come alone passive into the cell are getting help to come in through the proteins or other things? Certainly does it happen sometimes also to the other ones, or are completely different substances and it never happens? Then what is the explanation of why it never happens? And B, in mediated transport, an integral membrane protein assists a substance to cross the membrane. Uniporters move a single substance across the membrane, whereas symporters move two substances. Uniporters a single substance. So uni does not mean all, but single. But all are single. I am wondering about the prefix uni. Uniporters is the thing with uniforms. Uniporters move a single substance across the membrane, whereas symporters move two substances across the membrane in the same direction, and antiporters move two substances across the membrane in opposite directions. In passive transport, a substance moves down its concentration gradient. Whereas in active transport, cellular energy is used to drive a substance uphill against its concentration gradient. So concentration gradient, they said concentration gradient was, they didn't say it so directly. They said what we said there, just with the same words explained. What I understood from it, it just means there are more of it. And because there are many, they are just spreading into all directions. Technically, they're going into the places, so also they're lesser. But I don't know if it's spreading into all directions. And I never heard someone explain it. That would make sense, but also it doesn't make sense. Because there are already some of them. We cannot go where we already are. Water keeps standing very much as it is standing. If there's no waves, no wind, or someone mixing it, water keeps standing quite a lot, and it's not mixing so strongly. Water is not spreading to the side where water already is. They're just standing against each other. It is not so easily mixing. So it is not spreading into all directions. It wants to spread into all directions, but at some places there is already the water. If water would, dirty and clean water would be spreading. It is not mixing because there is already water standing. Only if someone, whatever it's called, blends it. And it goes into a site where nothing is. It just wants to go there. So that is what I understand from concentration gradient. Where more is, it goes into the sites where less is, because it's just spreading into all directions, has the effect that it goes where lesser. And the other thing was, it goes positives, what was it here? A positive charged substance will tend to move towards a negative charged area and the other way around. Extracellular fluid, plasma membrane, cytosol, okay. Concentration gradient. There are a lot of purple ones, and they won't go down. There are a lot of other ones, and they go down. So just accidentally do the same. Diffusion through the lipid bilayer. It was a question because it's not completely obvious. It seems logical that it is just accidentally or uncoincidentally that it is happening. But is it that actually? So diffusion through the lipid bilayer, like water, we said, I think water can just go through. Diffusion through a channel, it can just go through a channel. And facilitated diffusion. We didn't really say what is happening there. And active transport, ADP. The principles of diffusion, we're going to explain that later. Uniporters taking one specific in, symporters 2 in, and endoporters 1 in, 1 out. Okay, we read it, we got the overview. We're going to come back and read in the next parts on here, diffusion through the membrane, diffusion through the lipid bilayer, facilitated diffusion. If you were here for cytology, you can directly to the next part of cytology that we're going to read on. If you stay here and participate in the Extensor carpi and have strength training, men das werdet ihr auch das Good in stable stance, arms up, hands on to fists, bring your fists down. And fists like that, and down. And you can use now a towel, a t-shirt or a sock, and we have 3 rules. The first rule is stop immediately as soon as there's pain. Second rule, go only as far as it goes with a little bit of effort. And the third rule is don't overdo it. We just want to strengthen to exhaust. Press and down. Up. And press with all 5 fingers equally. Other hand. Press and down. Change, press and out, only as far as it goes painless. And with your hand, press and in. And press on top and down. Up again. And on the other side, press and down. And just press in neutral position. And that was the extensor carpi and strength training. I think you will watch next.